is a polymer called sodium tetraborate decahydrate mixed into polyvinyl alcohol. In other words, slime. Polymers are very large molecule structures that are chain-like in nature. To make slime, you must combine Na3BO4, which is sodium 3 boron oxygen 4, with 10H2O, so 10 molecules of water, also known as borax, in water. This compound is known as an ionic compound, meaning that it is a nonmetal and a metal. It's soluble in water and it dissolves into ions. This disassociates into sodium ions and tetraborate ions. The tetraborate ion reacts with water to produce boric acid and the OH ion.
You mix the boric acid into polyvinyl alcohol or glue, which will form hydrogen bonds between the borate ion and the OH groups on the sides of the PVA. This is called cross-linking. Also, when making slime, be sure to wear gloves or something to cover your mouth because you want to make sure that you don't ingest any borax, especially considering all the controversy surrounding reports that borax used to make slime may cause eye, skin, or respiratory irritation and may even cause seizures. Borax can be toxic at high dosages because it is essentially an overdose of the element boron. Iron, zinc, and calcium are required by the body too, but an overdose of any of these will send you to the hospital or even kill you.
Yes, and more specifically, borax is officially classified as a non-carcinogenic and a mild skin irritant. The high alkalinity of borax with a pH of 9.5 is what causes skin irritation, which is the same reason that washing soda and even baking soda can cause skin irritations too. So don't eat the borax, kids.
Hello? Is there any way out of this, please? Oh, geez. That's not the door. Is anyone in? What is that? Is anyone here? Can anyone help me? I'm stuck all alone in this smoke. Where is it coming from?
Caused by sublimation.
Jesus, Lord.
Ice, scientifically known as carbon dioxide, smokes in its solid state, which is what has caused the smoke you saw in the scene. Be careful not to touch it for too long because it can burn your hand after a while. This is because the surface temperature of dry ice is 109.3 degrees below 0 Celsius. If you were to touch it with your bare hands for more than a few minutes, it would cause nearly instant cell death or frostbite, which really hurts and may cause skin damage.
To create this smoke effect, you should fill a metal or plastic container half full of hot water and add a few pieces of dry ice every 5 to 10 minutes. As the water cools, you will need to add more hot water to maintain the fog effect. Also, normal air is 78% nitrogen, 21% oxygen, and only 0.035% carbon dioxide. If the concentration of carbon dioxide in the air rises above 0.5%, carbon dioxide can become dangerous. So, like Sophia said, carry the dry ice in a well-insulated container, such as a cooler. If it's transported inside a car or van for more than 15 minutes, make sure there's fresh air.
The smoking effect is caused by sublimation, which has to do with the intermolecular forces in the substance. For example, carbon dioxide is a nonpolar molecule, and the molecules are attracted to each other only by a very weak force called the van der Waals force.
Since the molecules are weakly attracted to each other, carbon dioxide molecules very readily go from the solid state to the gas state at low temperatures.
Hello? Is anybody here? Oh, a chemistry classroom. There's goggles. I better put them on for safety. Okay, hello? Is anybody in here? I fell asleep in school and I need help. A red flame? There's a fire! I need help! I'm all alone in the school! Where is this red flame coming from? Why is it not orange like most?
Why is this flame red? Well, first you guys are probably wondering what this experiment is called. It's called a flame test. The flame test is an experimental technique or process in identifying a metal from its characteristic flame color. For example, the metal that produced this red flame is strontium chloride. In order to conduct this experiment, you must take a wooden stick and wet it with some water so that the metal will stay on it. Then, place it into a small cup of the metal and place it over the Bunsen burner. Then you will see the color. Now, before explaining how this happened, it's important to know the safety precautions. As stated earlier, you will need to use a Bunsen burner, which means you must wear goggles. Why? Because the Bunsen burner flame can heat objects beyond 600 degrees Celsius. The blue flame, being the hottest, is not easy to see and can be very dangerous to anyone nearby. Also, when the Bunsen burner is unattended, it must be placed on the safety flame. We do not use the safety flame to heat the objects. Now, the flame becomes a different color because of the reaction between an element in one place is of the flame. In this case, the element was strontium chloride, which produces the color red. The normal electron configuration of atoms or ions in an element is known as the ground state. In this state, all electrons are in the lowest energy levels available. When atoms or ions in the ground state absorb energy, heat, electricity, etc., some electrons may absorb enough energy to allow them to jump to higher levels. The element is then said to be in an excited state. The electrons jump up to higher energy levels, fall back into their regular energy levels, and release energy in the form of visible light or color. Each excited electron in an element causes a different color depending on how much energy they release. An element can be identified based on this color. Only metals with their loosely held electrons are excited in the flame of laboratory burner. Many metallic ions exhibit characteristic colors when flame tested, and strontium chloride is the one exhibited here, which is why the flame is red. Stop.
I guess no one's here. Ella, where have you been? Ella, I've been looking for you everywhere. Ella, we need to go do our chemistry project. Come on. Yeah, well, can we make a thing of bloopers? It'll be funny.
Absolutely. Bloopers real.
Hi, guys.
I can read it like that.
Welcome to my crib.
I'm not like blind.
I'm TV, my crib.
Oh my god.
You mix the boric acid into